Uh, share. Cool. Well, welcome everyone. It's a pleasure being here. Been meaning to do this session for a while now, and for those of you who are new, welcome. My name is George Soto, one of the founders and co-organizers of Deep Learning Adventures, along with my colleagues here online, Robert and David. We're part of Data Community DC, a great community where um, thoughts, knowledge sharing, hackathons, happy hours, great networking sessions like this one happen. And we're part of a larger community where you have people from data science, data visualization, data engineering, statistical seminars. We have here data education that are part of our community. Some of our sponsor, Prefect, thank you for the place, and Jeff, and the food, and a great place to be here. So DC2 has we have our own Slack if you want to join us, and please join us. So I have a high level agenda here. This is for us, I would say the fifth session on our AI agent series. Might zoom a little bit here. There you go. All our sessions are recorded on YouTube, and you can find them on our meetup. So we started this journey a while ago with just some basic no-code tools. Then we started using the ChatGPT API to learn a little bit more how do we use this in the back end. We did some community projects, get an idea of, hey, what would you like to build using this tool? So we did a session there. People went off and tried to do things on their own. Something on UI UX and fine tuning. And then we started this journey on Llama Index, which is one of the, I would say, more developer friendly platforms for using generative AI. We use things on JavaScript. We did some agentic RAG, some event-driven document workflows. Last time we did some custom applications, and today we're going to talk about this. So I actually have, before I start the presentation, I have some questions for you. So if you don't mind, we have a QR code here. Just pull up your phone here and scan this QR code. This is an interactive session. Love to hear from all of you in terms of what is your interest, what would you like to see next, and so forth. So yeah, let me know when everybody's here. And for those of you joining us online, feel free to join as well on this QR code, or if you go to menti.com and enter this code, you can do that too. So let me see if I can do that in Zoom. Oops, sorry. Let me exit the presentation mode for a second and put it in the chat. Excellent. Okay, cool. So let me go back to present. All right, so let's start with the first question. Okay. Are you a new member? Have been with us for a while? If you don't mind picking one of the choices. So, new member, attended one or two events. I'm a pro. You've been here multiple times, just to get an idea of who you are. And if you're online, please participate as well. Love to get your feedback. Cool. All right. So I have a lot of several new members. Some of them you have attended some events, some of you are pros. Okay, tell us a little bit about yourself and your interest. Very high level. You can type anything. It's free word. Maybe I like applications of AI. Maybe I like finance. Maybe I like anything related to AI, I would say. Tech, LLMs, AI. Okay. Maybe something more specific projects. Okay. Maybe you founder. Okay. Sales, agentic, agents. Okay. Gen AI. Cool. All right. All right. Nice, nice, nice. Data. Okay. Cool. Nice. All right. And then one more. Some AI tools you're using this year could be anything from ChatGPT to Llama Index to V0 to any tools that you use this year. Any tools, just to get an idea of the audience of what tools you're using. So okay, maybe Claude, Gemini, Killer Code. Okay, that was your joke. I knew it. Gemini. It's over here. Like this. Okay, good. OpenAI API. Okay, good, good. Copilot. Yep, we use that as well. Claude, Anthropic, Hugging Face. Nice, nice, nice. All right. Okay, excellent. Deep research. Oh yeah, that's a good feature. Excellent. Right. Llama. Cool. And what are some use cases you're using? This is the last question for these AI tools. Are you using it for learning, for developing your project, for experimenting, for marketing, for sales, for trying to break something, for improving your workflows at work, coding, brainstorming, projects, writing? Nice. Googling, okay. Creativity, forecasting, okay. Fixing problems, I like that. Media analytics, cool. System design, research, drafting emails, classifications, media analytics, okay. Long reports, summarizing long reports, that's a good one. Excellent. Okay. So yeah, I wanted to just share a little bit about this so you can understand that there are multiple use cases. One person doesn't use them the same way as another person does. If you ask a random person here, yeah, well, this AI tool. Cool. Okay, let's go back to presentation mode. You see in Cherry Blossom here. So we have several new members here. So I'm gonna give you a very basic foundation of what we're going to talk about, and then we're going to focus a little bit on this main topic, which is evaluating large language models and agents, right? So starting with, if you're new into this, this is a very old slide from back when we started our community, actually from Coursera, actually. So in the back old days, you used to give rules and data to a program, and you get answers, right? So for example, if my speed is less than a threshold, then my status is walking. But that doesn't scale with data or situations. Now with ML, this is pre-generative AI, but it also applies to generative AI. We provide it with data and answers, and we get rules back, right? So we provide with lots of data. What does walking look like? What does running look like? What does biking look like? And then we provide it with labeled data. It identifies the patterns it needs to categorize it. Data is growing exponentially, right? So there's a research being done that for the next couple of years, actually, all the data that we've created is in the next 3 years is equal to all the data we have ever seen in the past combined. So the growth is exponential, and also this large language models and AI agents, their performance have improved a lot, right? That's what we've seen, especially since 2022. So anything from image classification, back in 2012, were below human performance, and visual reasoning and reading comprehension, things like that. Now they're human performance or even better than that. The structured fields, right? Things like mathematics, PhD level type of questions where research is needed, creativity is needed, and deep reasoning is needed. They're making progress, but I would say they're a bit more specialized in what they're trained. And if you ask them slightly different questions, slightly different domain, they might not give the answer you're looking for. How people use generative AI, in case you're curious, there was research done on 2024 versus 25. So people use it for coding, for learning, for fun, for creativity, right? For interview preparation, right? Generating images, that's another use case, education, and so forth. So different use cases, just for you to get an idea of what this is about. I'll share the links with you, but if you're new to machine learning or AI, there's some great resources there on how AI is trained, anything from neural networks. We covered this several years ago, actually. Kaggle has a great course on how to do this with Kaggle, how to do image detection, how to do things like that. There's great resources. Quickly going through what is different about generative AI, right? So now we have this multiple steps. The first one is called pre-training, where you have a large corpus of unlabeled text. Think of it as books. We take that, we hide some words, which is the concept of masking, and then we train a neural network, a large language model in this case, to predict the missing word. And this is the basic level of all large language models, of all AI agents you're going to see out there. They're able to look at the context, look at the sentence, right? They be trained to predict the missing word. So a lot of the strengths and also a lot of limitations come from this very, very basic, very fundamental design. Great, but if you take such a large language model, it might not work well for your domain. So that's where the concept is fine-tuning comes into the picture. Maybe you come from a healthcare background, from a medical background, from finance background, from human resources background. How do I customize it? How do I fine tune it? How do I provide my own training data so that it can work for my use case? That's the concept of fine tuning at a high level. Cool. There's a lot of concept here. Any questions, comments so far? Good. Okay. On Zoom, feel free to chat if you have any questions as well. Cool. This is one example of how you take the training data and customize it a little bit for your nuances. This is getting us closer to that version of large language models where they're able to follow instructions now. So for example, here we have the input, context word. The trophy doesn't fit into the brown suitcase because question mark or missing is too large, right? And then we want the reasoning model now to look at the context and be able to predict the missing word. And we have an output, and then this natural instruction data set here is rich in the sense that it has this reasoning. A human labeler went through this process of providing you the reason of why the answer is that, right? So then all these large language models now, if they've been exposed to only the input and the output, great, that's the minimum level they have to do. But if they have this rich reasoning behind them, that's when they can start doing some more advanced chain of thoughts, as it's called. Great. So how do we take that to the next level, and how do we come closer to instruction following or basically ChatGPT, a product that we all use? So we start with the prompt from our data set. We have, let's say, multiple prompts. We ask human annotators to give us their answers, right? In the end of the day, we're trying to replicate human reasoning. So we need lots and lots and lots of it. So we have human labelers writing the output of a very specific prompt. We take that, great, and then based on the previous fine-tuning mechanisms that we saw, we trained a large language model with its supervised data now to try to match the prompts to this output. Great, so we got some insights from there. The next would be, well, we need lots of it, but it's also expensive and doesn't scale too much, right? So what is the next thing we can do as a next level comparison? Maybe we don't ask the labelers to give us their raw output. We ask them to rank the output of a given model. So we take this model, we ask it a prompt, it will give us 4 different variations. We ask it which one is better from a human perspective. It will rank it for us. Now, this human labeler ranking now is also important for a different neural network called the reward model. That one is trying to understand a little bit better if 4 humans give you 4 answers to the same question, which one is better from a human perspective? Which one aligns better with human preferences? So this is the whole point of this reward model, to understand a little bit better those nuances. Cool. So we have a model that generates outcome. We have a model that kind of understand a little bit better human preference. How can we combine them? So then we have this policy with reinforcement learning here, where we sample a new prompt, we create an output, right? And now we have an idea of how human preference works. We can give that to this reward model. It will give us an output. We'll see how good or bad it is. We'll give it back as an input. So we have this loop now of these 2 models that we have, the content generation, I'll call it model, and the reward model on human preferences. Well, we can chain them together, and we need some kind of a loss function here. I'm simplifying it a lot, but you can see that we have now 2 building blocks. One generates content, one ranks it. If given enough training data, this will converge to a nice solution here. So yeah, these are the building blocks of pretty much every instruction following what is called large language model, in the sense that they've been trained in this instruction format, that you have a prompt, you have an answer, they can generate it. Cool. How do we do this at scale? So this is from Llama, right? Llama is one of the open source models, and right now I think we have the 4th version. This is from the original paper back in 2023. So this is the data they use. They use a lot of internet data, around 3 terabytes of it. C4 is also like forum and internet data. GitHub, a lot of coding. Wikipedia, we use Wikipedia every day. Books, a lot of books, anything digital, right? That's out there. Archive for papers, just to expose it to more nuances. And Stack Exchange, anything on how do I do this? This is how you do it. Anything on instructions, basic, and forums. And then here on this slide, you can see for given how much training data in terms of tokens, in terms of words that these models are exposed to, what is that training loss? And we want it, the smaller this loss to be, the better. So in blue here, we have the 7 billion parameter, the smaller model. In orange, we have the little bit bigger one, 13 billion, 33 billion, and 65 billion. So the bigger the model here, the more it's able to learn the patterns, but also it's also more prone to memorizing the data, right? That's why you need a lot of validations happening here. Great. Then how do we evaluate this on different sets, on different data sets? So I showed you one, the natural instructions one. There are multiple other data sets out there that these large language models have been trained on. Trivia QA is one that has trivia kind of questions, you know, is Pluto a planet, yes or no? Or who is the author of this book? Or who is the artist behind this famous song? We have a lot of trivia questions there, natural questions, a lot of math questions here. And you see the performance here. It's not uniform, right? Because maybe it's been not exposed to all these topics. And you can see that at some point they start learning all these patterns here. Cool. Last slide on the training part before we go to evals is, well, this is great on, you know, text, maybe English or other languages, but does it only work in text? Like, no. The lesson I wanna share here is that this works on any sequence, right? So in the text world, we have sentences, right? We have a subject, we have a verb, we have an object. In, let's say, in the medical world or in the physical sciences world, the protein sequence, we have different structures, but there is a structure there. So the lesson here is that anything that has a structure to it, as long as there's a sequence of numbers, think of it as like an alien language, there's a structure to it, we can learn patterns from it, and we can build these large language models on. Cool. That was a lot. Questions, comments so far? Maybe a chat, let me know.
Why do you want to different size of large language model?
Why do you want to have different versions of them?
Yeah, fine. Who do the other one? Yeah, fine.
So this is the performance of multiple of them. So the blue one is the smallest one, red one is the biggest one. These are training data sets. This is their performance on different training set. So let's say you train your model on this training data. Now you want to ask it, well, how good is it in asking math, in answering math questions, biology questions, chemistry questions, coding questions, scientific reasoning questions?
I mean,
Because like why, right?
I mean, why wouldn't you choose the large one? Because that gives you
Oh,
the best result.
Well, it comes in terms of size. This 65 billion parameter, it comes in terms of size.
Yeah.
So how would you run it, right? It might not fit in your browser. You might need two GPUs to run it. So it boils down to infrastructure. Yeah.
So just a follow-up question.
Yeah.
If say you had a trained data set that was yours, you raised it by yourself, would there be similar spread in the accuracy of models with the bigger parameters and the smaller models?
That's a good question. So you're saying instead of using this data, you fine-tuning it to your own data set, would this behavior look like this?
What the fine-tuning of?
Usually when you fine-tune it, your data set, I don't know about you, but I don't know if you have 3 terabytes of data sitting there, right? Or 300 gigs of data. Usually your evaluation data set is much smaller, and I can probably estimate that even the smallest model here, even the 7 billion parameter one, would be able to maybe just memorize it. That's why you need to have a good held-out set, a good validation set, where when you train this, you need to make sure that it doesn't memorize your training data. It needs to understand the patterns, but not memorize it. So the larger the fine-tuning set, the better. But also when you train it, you need to make sure that there's many techniques you can use to prevent it from what's called overfitting, from memorizing your custom data. Cool. Switching gears to evaluations now. So I wanted to have that foundation level just so I understand how they're trained, what are their strengths, their weaknesses, and so forth. So This graph here is from a basic, from an initial paper where different behaviors of large language models appear based on their model size. So the smaller the parameters the model is, it can do basic things like language understanding. And then the more parameters we add, it can do like question answering, it can do better math, it can do better summarization, it can do better knowledge. I just show you that. I mean, it's something that we know in AI and deep learning, that the bigger the model, the more its learning capabilities are. Yeah, right? But I wanted to have this because there's many large language models out there with different skills and capabilities. So then the question becomes, okay, I want to build something. Which one do I pick, And without having something concrete, something to measure, you cannot just make a decision, right? So you need something quantifiable, you need something tangible for you to make a decision. That's why eval metrics are a good reason. Then the other thing is, well, you have these humans now, we'll talk a tiny bit about AI agents, you have now these tools. How can we combine them to solve a business problem? And without having specific, metrics and specific quantifiable outputs, it's hard to know that you're heading in the right direction. Let's say you're solving for a problem, you want to increase, I don't know, your website visits or increase your marketing sales, whatever that might be, your sales. How do you quantify that? How do you make sure you're heading in the right direction? Then at the end of the day, evaluations is quality. Good evals throughout the process means your product in the end will be high quality. So this is an example of what happens when maybe you miss that quality or evaluation step. So there's some examples here. This I think is from 2023. Air Canada, right? They had they had an AI system on their website that they wanted to quickly roll out, and one of their users used it. They were, according to the AI assistant, allowed to be refunded by the company. Well, it turns out that the AI assistant made that policy. The human assistant said, well, that policy doesn't exist. Sorry, try again. Customer was not happy. He ended up in court with Air Canada, and the judge said, well, this is your product. You're responsible for its output. You need to take care of your customers. So that was something. And then the other ones is here from a car dealership, right? Somebody tries to trick this large language model into buying a car for $1 here, right? It's a legally binding offer, no Texas waxes, right? So, it's something that you don't want to see your products, right? And before we talk about how to evaluate them, I just want to spend 1 second here on the different choices of how can we combine these different solutions, right? So let me go here maybe. So you'll hear me talk a little bit about tools and large language models. Well, how can we combine them? And then you'll see in a few slides how do we actually evaluate them. So the simplest thing you can do is just have large language models access tools. That's the simplest approach you can have. You can have a network approach where each tool or each LLM can access each other. You can have a supervisor type of approach where maybe you have a entry-level large language model. It's not specialized in something, but it's really good at routing the request to a specialized output. You can have hierarchical, custom, there's multiple choices for this. Use cases, people use this for customer assistant, for employee type of work where employees are using them internally, for creative work, for coding, for data analysis, for security, some use cases, and there's a slide here with multiple of them. Okay, cool. So what is the basics of evaluating them, right? Let's say you want to build a product, and this is how humans would build it, right? You have maybe a product manager giving you the product description, maybe an architect designing the architecture, maybe a project manager making sure everything is running fine, the engineer, the actual who builds it, and the QA engineer. Let's say you build this with large language models or agents, as you'll see. How do we know they're heading in the right direction, right? How do we know they're doing well? And this concept of large language model as a judge, this was introduced by Anthropic actually, comes into the picture where you have this idea of let's use this constitutional AI feedback for improving our performance. So let's have another AI model evaluate the first output of a model, and let's also reason why it's meeting a specific criteria or not. And the other thing is, well, what can we use for evaluations, right? If you use humans, that's the best, but it's too expensive. Think of it as, can you use humans as evaluators for all your outputs? It's too expensive, it's high quality. Okay, what about traditional natural language model evaluations? A little bit too syntactic. That's why large language models have a good balance in terms of they're meaningful, but also they're scalable in the sense that you can use them as another evaluator. Great. So let's see how this works in real life. So we have a user, they ask a query. Our data is somewhere in the backend, it's indexed. This is the typical architecture of something called retrieval augmented generation. The first thing we have to do is we have to find the relevant documents. After we do that, we have to provide it to the large language model, and the large language model will look at the prompt, the retrieved documents, and it will generate an answer. Well, what are some things that go right and what are some things that go wrong here? If everything works fine, we get an answer, great. But let me give you the analogy of what this looks like. Let's say I'm looking for an answer and the answer relies on a specific page or on a book in my library, in my nearby library, right? So the query would be, what is the DNA structure for specific organism? That answer is somewhere in a book in the library, right? So when we talk about context and specifically context relevance is, well, did I even go to the right library? Did I even go to the right section to find that information? So in our context here, when I did the search, did my retrieval system find the right context, find the right documents for me to analyze? Am I even in the right room? Do I even have the right information on my table? That's the concept of this metric called context relevance. Is the retrieved context relevant to the query? Great, let's say I retrieved it. I'm looking at this book, I'm looking at the answer, and I'm generating a response. The DNA structure for this organism is XYZ. Did I back that up based on the book I just read, based on the information I just found from my backend system? Or did I just make that up from the training data that I was trained on? You saw the terabytes of data that these large language models were trained on. This is where the concept of groundedness comes into the picture. And then great, let's say I follow the first two steps. Well, I generated my response. My question was, what is the DNA structure of this organism? Maybe my answer is, organisms have different DNA structures. Okay, is that relevant to me? Okay, it's kind of, but not really what I was looking for. So how relevant is my answer to the user, right? So we have three evaluation metrics here that we can use. Did I find the right book? Was my answer fact checked and based on my book? And most importantly, did I answer the question that the user had? Cool. These were three metrics that we can add. There's a few more on this RAG triad that this company called TrueLens, now acquired by Snowflake, introduced. But there are several more that we can incorporate into our processes. The first three we covered are under this honesty pillar, where the answer is relevant, the context is relevant, it's grounded. Maybe we can look at more technical metrics like embedding distance from our query to the actual data. We can look at something called summarization quality. So how honest, how based to reality or based to the training data my answers are. The other side of this is when you do evaluations is harmless, right? A lot of people might want to jailbreak. This jailbreaking is where people are trying to, as you saw in the car dealership approach, trying to make the LLM do something that it was not designed to. Maybe it's stereotyping, right? Maybe it's toxic. Maybe it has private information in the back end. Let's say you have your own model, you're training on your own company data. Maybe the training data has not explicitly PI information, but maybe there's patterns there that have some kind of PI information, so we want to include those as well as part of your evaluations. And then most important, helpful, is this answering a question or is it just an output of a model? Is it concise? Is it coherent? That's another metric you can add. Cool. So this is an example how this would look like in real life. Let's say we have a prompt here. Did Einstein contribute to the development of the atomic bomb? And the answer is yes, Einstein did contribute to the development of the atomic bomb. And from answer relevance, the answer answers the question. Great. Let's go to the next one. Well, what is the supporting document for this, right? What is the context relevance? And if you look in the training set, there's no specific mention of Einstein doing this. There is a mention of him winning a Nobel Prize in physics for the law of photoelectric effect, but there's no mention of him developing the bomb. So groundedness is 0. There's no fact check. There's no actual grounded information on it, right? So this is where you see the 3 different metrics being very different. One is yes, answering the question. Second one is, well, there is a little bit of physics. He is a little bit involved with, I guess the fundamental laws of atoms. But if you actually look at the facts, there's nothing specifically mentioned, right? So that's how to use it. Cool. Another tool is this LLM comparator. You want to compare different tools. And actually, there's many tools now that you can. I'll show you another one in a second here that you enter the same prompt into multiple large language models. You want to see how they behave. And if you expose it to your company data, maybe one of them might be very good with financial data. One of them might be better with health resources data. One of them might be much better with coding data. So these tools allow you to compare different large language models and maybe pick the one that is most relevant to your business. Cool. That was a lot of questions on large language models. Before we jump to agents, any questions, comments? Yep.
How does the evaluation score work? Like, what's 0 versus what's like 10? How does it?
Yeah, usually it's 0 from 1, and in this case, the example that I'm showing, you can use a large language model to evaluate a secondary large language model. So let's say I'm using Llama 3 here. Maybe I'd use another one, let's say Claude 3.5 to evaluate my Llama 3. And the score would be a very specific prompt. Let's say based on, for example, let's talk about groundness. Based on the answer, and we can look at the actual code. The prompt is very lengthy. Based on the output, how accurate, how grounded, how fact-checked is my output based on the retrieved information? And you can also give some examples, from like 0.
Criteria, things you were looking for.
Yeah. The prompt is actually almost like a page from a book. It's very lengthy. But how would you as a human categorize, like instill that instruction? Let's say you as a human evaluate if this is grounded, right? How would you do that?
The thing is, like, when human does it, it's like very subjective, and
Mm-hmm.
put it into a score, it's kind of hard to, do this. I was wondering how the LLM does it come up with this.
Yeah, it's not quantitative by any means. It's maybe some examples are there in the prompt, but 0 means this is completely not found in the training data or in the reference data. 1 means you literally found this answer in the reference data. And somewhere in between is you let the large language model make the distinction. That's why if you switch your large language model evaluator, your scores will also switch, right? It's like having a human judge. Somebody's performing, okay, maybe they're biased, maybe they have their own upbringing, right? You switch the evaluator, the scores are different. So there's no like clear answer. This is how you do it. Half means half the answers are there. 0.7 means 70% of the answers are there. It's like a spectrum.
It's got average multiple raters, but
Yeah, you can have multiple, exactly. If you want to be really, really into it, have 3 evaluators and get the average.
So it's not based on cosine similarity.
No, it's based more on like you giving a evaluator LLM. This is my output and this is my reference data. Is my output backed by this training data, by this reference data or not? Is it in alignment? Is it explicitly mentioned? Is it even close? More than similarity.
But that evaluator based on large language model.
It's a large language model itself. Yep.
And
yeah.
how do you combine these 3 scores overall?
It goes here to this LLM evals. Yep. You don't combine them. Each one of them is different. So yeah, each one has its own metric, right? So you have 3 numbers now. This is how it look like. Maybe you have a version of your app. This is how much tokens you've used. This is what the cost. These are your metrics. And then you'd improve let's say you notice, okay, maybe my groundness is not working. Well, why is that? take a look at your retrieval information, maybe, or your context relevance has an issue. Maybe my retrieval needs to improve in the sense that when I find here the right information, maybe I need to look for synonyms. Maybe I need to look for similar prompts. Maybe I need to rephrase my question so that I can retrieve the relevant documents. And then you get better scores and better scores and better scores, hopefully.
So this is basically like evaluation for for example, it could be like a prompt. So you're constantly changing your prompt, and then your evaluation goes up, and you're fine tuning prompt to make it perform better.
Yeah, let's say you have a collection of prompts, you run it through this, and let's say you notice that your context relevance is low. Maybe you change the way you index, maybe you change your embedding model, maybe you change the database you're storing the data, maybe you change something on the retrieval side. That will improve your context and groundness information. Yeah.
My question was actually related to that. I've been looking into this and I've found a lot of tools out there for doing LLM evaluations, but not much for doing prompt valuations. Like, yeah, I have a very simple use case of, say, like, categorizing a social media post into different categories, and I've created a prompt for that. I want to see how well that prompt works with, say, a single LLM. And I want to try out different prompts and run the same evaluations there. I haven't been able to find a good tool that I could use it in production so that, users can tweak the prompts themselves.
Yeah, I'll share with you. Let me see. Yes, I see some questions in the chat. Let me exit presentation. There's this good paper on RAG pain points. Let me see if I can find it here. It's an image actually. It's this one here. It's from a paper. Okay. This is now zooming into that RAG system, but like really taking a close look. So a lot of things under the hood in terms of when you ingest the data, how you store it. Maybe you have ingestion scalability. That's one problem. Maybe you're missing content. But in terms of query, right, there's a lot of things you can do to improve your output. The very first thing you can do is you maybe have a specific way of asking a prompt. I have a very slightly different. Jeff might have it slightly different. So the first thing you can do is you can rewrite it. You can ask a large language model, hey, what is the DNA for this organism? You can say that in 20 different ways. This organism is comprised of this DNA. In basically rewriting it. Then you have a new query that's now from one query you went to, let's say, 5 queries. You ask them all of them in parallel. And you retrieve the right information. You might re-rank them based on some kind of metric. You might say, okay, this answer is higher in rank. Based on other metrics, you might consolidate them, you might read them. So there's a lot of improvements you can do in this pipeline. And all these red points, everybody thinks can go wrong, and and how you can solve it. So I can share this as well. Cool. Let me see in the chat. For the evaluation metrics, answer relevance, will you perform manually or there are automated tools? Yeah. Roman? LLM based, exactly. And if it's mission critical, then maybe you have a combination of LLM and human evaluators. Okay. Cool. Let's go to agents now. So this is great for large language models, but what about agents, right? And what is unique about agents is, go back, is now large language models that have access to tools, number one, or they can communicate with other agents through protocols like MCP or A2A. And when you have let's say a specific business metric in mind, like revenue or user engagement, great, that's useful. But these agents are designed to do a very specific goal, like a very specific metric. So, for example, they can do maybe like completion rate or goal, or maybe they can do some kind of quantifiable metric. They can look at that and optimize that. So these are the specific goals. We'll look at some examples here. Another one is when you run these agents, some of them will have, latency issues. Some of them will have errors. How do you track that? So you need some kind of telemetry metrics as well. And then humans, when you interact with the systems, you want to give them the ability to do like a thumbs up or a thumbs down. I like this answer, I don't like this answer. So human feedback is important, as well as ask your testers, right, and your subject matter experts, your customers eventually, what do you think about this answer? So then you combine all these key performance indicators. So that's a good list of performance indicators to use. So let's use a very simple agent here. My agent has a starting point. It has access to different tools based on the prompt. And this very simple agent can do two things. It can get the price for a product, or it can get more information about a product, right? Let's say I'm running a very simple e-commerce. I sell 10 things online. Each one of them has a price, and each one of them has a product description. This is like the MVP of like an AI e-commerce assistant. So what can I do here? I need to evaluate its capabilities, right? When I ask a prompt, is it giving me the answer? Is it smart enough to understand the nuances of a price versus a product details? It's important, right? Number two is I want to evaluate when I give a prompt, what is called the trajectory and tool use. As a human, if you ask me a question, how much is this product? I'll probably pick one path in this workflow. If you ask me what is this product about, I'll probably go into product details. And then at the end, the response, right? Similar to what we saw for large language models, the relevance, the correctness, the quality. So we need a user prompt, basically. We need an evaluation data set. This is where this AI agent evaluation comes into the picture. We need a user prompt. We need what is called a reference trajectory in terms of what we as humans expect. And we need a generated trajectory in terms of what this AI agent selected. And then we need a response. What does that look like? Let me hide this. This is a simple evaluation data set, right? I have my prompts, get price for smartphone. I have a reference trajectory. In this case, I call the tool called get product price. I have a predicted trajectory, and then I have the actual output. If this matches, if the reference trajectory and the predicted trajectory matches, great. If there's some kind of discrepancies, that's where the evaluation metrics would pinpoint. So if I'm asking about product details and price, I'm asking about two things. The trajectory would be two paths in my reference trajectory. And maybe my model just executed one path. Maybe it just gave me product details and completely forgot about price. Details, again, product details, price, right? You can see here the information. So for example, here I was asking about product details and price. I only got price. I was asking about details. I got details. I was asking about details and price. I only got price, right? So maybe it followed the right path, but the response did not meet both my criteria. So we have this evaluation data set, and this is a very critical asset that you have to create internally. Somebody has to go through this process of creating the prompt, what you as a human would expect, and what you expect as a response. And then how can we evaluate this list, right? Now this becomes an evaluation of these trajectories. Well, if your criteria is very strict, right? Maybe you want to do exact match. You want your reference trajectory and your predicted trajectory to literally match, even for a very complex prompt. You want the tools, the order of the tools, everything to match to the point. Maybe you're a little bit less flexible and maybe your operations are commutable, meaning any order. Like you can get the details first and then the price, or maybe you can get the price first and the details. It doesn't matter. As long as you get both, any order is fine for you. So you have multiple basically metrics depending on how strict you want to be with your evaluations that you can incorporate. And then when you evaluate them, you want to say the precision, right? So did I let's go back here. Out of the reference trajectory, did I get all of them? Was my precision high? You have other metrics. Did I miss any of them? Right? This is typical in when you compare to different data sets. Did I miss a single tool? Maybe a tool that I was supposed to use, but I didn't use it. That would show up as well. So then in the architecture point of perspective is I have a user question here, right? I have a large language model that decides which tool to use, some kind of router. And the first question is the output of that would be, well, did the router pick the right tool to use? That's number one. Number two is, let's say, to pick the right tool to use, it used to it call the tool. Did my tool give me the right answer as I expected it. That's another metric I can add. I get the tool response, and maybe I give the final answer. Is my final answer satisfactory in terms of what I expected as a user, right? So I can have one metric here, one metric here, and one metric here. Can evaluate this on multiple records from my evaluation dataset and can see how they perform. This is the only page that I'll show a little bit of code. So this is how you do this. This is on Google Cloud, on GCP. They have this eval task module in Vertex AI. In this case, I'm looking for multiple metrics just to see how this simple agent is working. So I'm looking for exact match. I'm looking for in-order match. I'm looking for something called safety, making sure that going back to responsible AI, how safe and this is to use, or if it just follows the trajectory. So I'd import the libraries, start the session, define the evaluation task here, run the evaluation. This would run. You would get some metrics, and when in the end you're gonna get this, let's say, exact match, a metric from, in this case, from 0 to 2 that tells you on average what is my response, right? So let's say I have 100 such evaluation sets. On average, what is the exact match? Did I get 10 of them right? Did I get 20 of them right? Did I get 100 of them right? What does that trajectory look like? If I care more about safety mean, I can maybe focus on that, or maybe some other metric, I can focus on that. So yeah, this is something that a lot of companies are using. Going back to the question of human versus large language models as a judge, right? So there's a comparison here. We use humans to do all this. We're great for nuanced behaviors. We can consider human factors. We're good at that, right? The weaknesses, though, is that our answers are subjective, right? It's time-consuming, it's expensive, and it's very hard to scale. And we've used large language models on the other side as a judge. They're scalable, they're efficient, they're consistent, but they're not quite there, right? They might overlook intermediate steps, and also the reasoning capabilities might depend on their training data. You can also use like automated metrics, and usually a good combination is between humans and large language models. That's a good combo. This is important because that very simple AI agents that we saw does one couple of things, but in real life, you might have more complex multi-agent framework, right? Where you might have a user, you might have a router that gets the prompt. Based on the router, you might defer the prompt to the specific AI agent, let's say a researcher. The researcher might give you an output. Okay, great. How do I visualize that output? Maybe you call a chart generator, code generator agent. It generates the chart for you. He calls some tools in the back end. He gives the answer to the user. So there's a lot of agents here, and each one of them you need to evaluate separately first and then together in terms of all these metrics that we saw. Then another trend that I see on AI agents is this concept of contracts, right? This reminds me a little bit of like promises, like in object-oriented world, where you say, this is what I need to see, figure it out, I delegate it to you. As long as this task met in my contract, then we can proceed to the next step. So this concept of contract for AI agent is also new. Cool. I'm gonna pause here. I spoke a lot. I want to make sure you got all this. This was a lot of content. But yeah, let me know if you have any questions, comments, feedback on this, and let me know how we're doing with time. It's almost late.
So do you have to build the agent yourself, or are there tools to help you build the agent?
There are many tools that help you build agents. Many tools. Yep. But few to evaluate them. Much fewer. Yes.
What is 0 to? Is it 2 better or 1 is better?
The higher the better. I think this is based on either some kind of average based on your records, or it could be a number of records. You can configure it. Let's say I have 100 records. Give me the count, or give me a percentage, or give me average score across all my records from 0 to 1. Let's say in this case I got 1, 1, 1, half.
It looks like you're using Vertex AI for the agent evaluation.
Yeah.
So it's provided from the people.
Yeah, I mean, I just like the way they they explained it the way they presented it, and it's very easy to run. But
And then there's tools like that for the LLM evaluations as well.
yeah. If I exit the slides here, I have several tabs open on how you do this in code with other platforms. Yeah. I wanted to keep this at a high level so that you're aware of how this works, and then take a deeper dive in the next section technically.
Just on the kind of the little chart there, there is a Hugging Face space that has a bunch of agent leaderboards, which is
Okay.
kind of interesting. There we go there if you don't want to, but you can if you want. It's huggingface.co/spaces/Galileo-AI.
Okay, yeah, Galileo is a startup that does a lot of
Agent
evaluation.
leaderboard. Yeah, the second one down there. So.
Oh, leaderboard, got it.
It's pretty interesting. They've got
Everything
comparisons,
models.
and if you keep scrolling down a little bit, they've kind of ranked them there, and if you can check out individual ones, and it'll give you that spider chart across a whole bunch of different evaluations, which is kind of cool. But yeah, it's interesting.
Nice performance.
A lot of stuff. Yeah.
Okay, this is cool. Yeah, I'm curious on this average category score.
Yeah, if you go up a little bit, maybe. Click on.
What to evaluate? So interactions, function composition, error handling.
It's a little different.
Was that a agent framework? Was it solid?
Yeah, Galileo is a startup that does a lot of evaluation, so they probably have their own framework, and that's.
Yeah, click on model comparison right there. I think that's up above right there. Yeah. That shows.
Oh, cool.
Like,
so yeah, single field performance, multi-term performance, yeah.
And their own.
And these are their own data sets, probably, yeah. Tool missing,
Data sets.
irrelevance. Yeah, this is cool. And this is which model is this? Claude. Okay. You can add maybe Gemini, right? And you can add maybe DeepSeek and GPT-4o, right? And you can see how they overlap. Some of them are. Here, let me keep just to it. It might be hard. Let's do.
Was that a cloud? Was that a model or like a framework agent?
Yeah. So if you go here on the data set, you would actually see how they evaluated them. I have a blog here on how the evaluation work, and they have their own criteria, right? That's what I was telling you. They can have your own custom evaluations. That's what they did here. Okay, long context. Okay, some of them do good with context, some of them don't do good with context. Cool. This is cool. Data exploration. If you want to look at the different data sets, let's say evaluation matrix, tools. Yeah, so the question could be, calculate the compound interest, right, based on this amount. Final response, do that across multiple LLMs, evaluate them. Could be more like a quantitative. Oh, here these are the different data sets. Let's do one on long context. I saw many of them. My name is this. Cancel the whole order. Okay, this is what I did. Let's pick maybe a different model. Oh, this is cool. We can pick different, maybe a smaller one. Let's say any llamas that are small, maybe, or maybe Palmyra. I like some close ones. Okay, maybe a smaller one. We can pick small, Mr. Small, maybe. Final response. Nada. Okay, we have to. I don't know. Right. So you get the idea. You can evaluate them. Cool. Let me just quickly cover this topic of responsible AI. I think there's a lot of conversation on how do we, use this or abuse them or not use them, right? So I recommend checking out these resources. There are some great books you can read if you want. So one is on this automatic inequality. So what happens if you use these models and put them now in decision-making setups? This book covers what can go wrong with that. So people applying for loans, people applying for healthcare, people, being miscategorized, you name it, and anything can happen when you don't have good ethical and responsible use of these tools. These other tools here, predicting machines and power prediction, they talk a little bit more on the economics of AI, and how AI will change our landscape. And this book is also a great one from Professor Feifeli on her experience with these AI tools. And then here I have just one example of jailbreaking, and I mentioned during the talk earlier that there's a session actually going on here. I'll share it here in a second, but how do you break them? How do you make this large language model do something that we're not designed to do, That's the whole point. So jailbreaking, then policy, right? Policy now, think of it White House, think of it like country level or state level information where a policy now impacts the entire industry. So US is a little bit more on the let's explore these AI tools, let's be more adventurous. Other continents like EU are very protective. They have very specific use cases where you're not allowed to use AI. For like credit scoring, for example, you're not allowed to use behavior manipulation, no. Biometric categorization, no. They have high risk AI that they need pretty much a lot more from you as an industry to provide them before you can use them, and then low risk that you can use. So yeah, I wanted to share with you these resources, and let me share with you this hacker prompt. This is the second version of it, where you get paid actually to hack OpenAI, right? So ChatGPT. So they have multiple. They have an entry level track. They have one on biological, chemical, breaking. They have one on tricking agents, on giving you personal information, cause harm, things like that. So yeah, take a look. This you need an account, but this is a ongoing, and you can see, people are performing here. What are some points they've collected, the teams, and once you join, you can see more about it. They actually there's a paper called Hacker Prompt paper based on the findings, the findings of the first version, and here they have a categorization of the different approaches they followed. Let me find that somewhere here. Of few shot, maybe you give some examples, maybe you have simple examples, maybe you do distraction, maybe do recursive, maybe you obfuscate something, maybe you hide it in different, maybe you convert your prompt to base 64, context switching. There's all of those. Pick one task here, and there's a whole category of those and how they perform, right? So yeah, now translate the following to Spanish, or use different languages. There's tons and tons. Let me show you some examples here of how you can do that. Cool. And then for next sessions, we're going to follow some resources from Deep Learning AI. There's some great resources on evaluating large language models and agents practically and technically. So weight and biases as one, Y-Labs as another one. We've covered this one on Llama Index, building evaluating advanced RAG systems. This company has one. Guardrails, red teaming. How do you do red teaming, right? How do you do now all those negative contents at scale, and how do you evaluate their output? Accuracy, safety and guardrails, that's important. And then evaluating on RIs. So probably going to start with this one. Yeah. So yeah, that's what I wanted to chat. Appreciate your time here, and thank you for your questions. And if you have any comments, let me know. And then fast food.
What was the last of the archive?
This is called Hacker Prompt paper. If you just Google Hacker Prompt paper. Yeah, I'll put in the, ignore this title, Hacker Prompt. Yeah. Yeah, let me know in the chat if you have any questions, comments, feedback. Hacker Prompt paper. There you go. Okay.
You gonna share the slides as well?
I'll share some links. I'm still working on the slides, so I'll share some of these links so you can have them. Yeah.
So George, earlier you said combine supervised training with the reinforcement learning. Can you repeat that again? How did you combine those two approach?
Are you referring to this slide maybe?
Yes.
Yeah, so this is a very famous paper from OpenAI team of how they approach this here. If you open this paper, you can learn more about it. But this is one of the the very first Instruct papers back in 2022 of how they performed this this approach. So I would say, yeah, just Google what is the name of the paper? Training large language models, full instructions with human feedback. It's a whole paper. It'll take you a while to overview. But at a very high level, you need two things. You need one model that understands prompt generation. So no, not prompt generation, answering prompts. So content generation. And then you need another one that kind of understands human preference. You need those two building blocks to iterate them in a loop and give you good quality answers. It's harder than it looks. I mean, OpenAI spent millions of dollars on this and lots of data. A lot of experts in reinforcement learning. Cool. Thank you, Roman. Okay.
May I ask you something?
Yeah.
Can you go over to the slide? There was a slide with a table that it was when you were discussing the trajectory, the predicted trajectory, and the response. Yeah, there was a little bit.
Maybe this one.
Yeah, that one. Can you go over that one again? You were referring like this is like something that you'll need to do, I guess, the evaluator.
Yeah, this is your evaluation set. So you as an evaluator, as a team, you need to create this. So in the traditional machine learning world, you have your training data, your validation data, you have your testing data. This is something similar to the generative AI area where you have now multiple prompts, like what would you like, what is your agent doing? In this case, my agent is just answering questions about a product or giving you pricing information. So you as a user, what kind of questions can you ask? I can ask about a price, I can ask about details, I can ask about information, I can ask about how does this product work, what is the price, some basic prompts, right? And then that's the prompt. What do you expect as a user, as a human? If you went down this path, this trajectory here, what would you do? So if I asked you, what is the product details and prices for headphones? Well, you need to call these two tools. There's two tools you need to call. One is the product details with headphones as an input. Let me zoom in a little bit. Sorry, let me exit so I can zoom in. There you go. And the other one is the product price with input as headphones. So that's what you expect, right? That's what you would do as a human. Well, what did the model actually do? That's the predicted trajectory. And then what is the final output of this? What do you expect? So this is your predicted response. You can also have a expected response and see how they differ. And now you can do two things. You can compare how the trajectories match based on how sensitive you want to be. Do you want exact match or any order match? And also the response. How helpful is the response and how accurate is the response? Those two metrics.
In this context, expected is like the reference one, and predicted is the one that the model.
The model created, yeah. And then you notice, hey, my predicted trajectory for this agent is really low. Okay, what is the problem? Then you take a closer look. Yeah.
Thank you.
When you evaluate it, is it gonna be part of the agent itself, or is it could be like separate third, like looking at it from outside, looking at agents?
You mean how is this?
How does it get the value, well, expected trajectory, yeah, humans are gonna write it, but how will it get the actual trajectory?
Yeah, the framework you use when you write a prompt, it will actually tell you, we saw this in Llama Index, it will tell you, oh, you're asking me this prompt, I'm calling this tool, and this is my output.
Yeah, so that evaluation, so I'm guessing this is gonna be the automatic evaluation.
Yeah, so you do that for one or two prompts to get an idea of what the framework looks like, and it looks like this. It has a structure, it has a tool name, it has a tool input. You do that for a few prompts, and then you as a human now, you can create this reference trajectory. And then when you run this through your model or through your agent, you'll get the actual predicted trajectory, what your agent did, what path it took. And then, I mean, these are in this case, just Python objects. The order doesn't matter. But you want, for example, if you're very specific with maybe timestamp or maybe very specific in which path an agent took, you would catalog that, and now this becomes now a trajectory matching or trajectory comparison. It's like Google Maps, right? You can go from here to here in 10 ways. Well, maybe you have an ideal trajectory, or maybe somebody did loops, and then eventually ended up there. You would
I was
put it
asking more
lower.
about like how you use the evaluation. Will that be part of that agent flow, or will that be?
Yeah, the evaluation tool. So once you have this data here, let me make this bigger. Once you have this data, it depends on the framework, right? How it's designed. For in this example, I have this, I have my data set, and I have a very specific agent that this framework will run its prompts through the agent, and it will look at your evaluation data set, and it will tell you on average how it performs. So the framework also needs to be helpful in this case. If I answered your question correct. Yeah, so you can get this. But the framework needs to understand what is a flow, what is a trajectory. Cool. Any more questions? Okay. I'll stop sharing for the Zoom folks, and I'll post the recording on YouTube. And if you have any questions, feel free to put them in chat. Otherwise, we'll see you guys next time. We'll dive deeper on maybe more technical session, right? On how do you do this code now in notebooks. But I didn't want to throw the code in notebooks now, because you'll be like, okay, what is groundness? What is context relevance? You know, why should I do this? Why should I do that? So I think this was a good approach. Okay.
Cool.
Thank you so much. Appreciate it. Thank you. Thank you for coming. Thank you, everyone. Thank you all.
Right, grab some pizza on your way out. There's some extra pizza, so feel free to grab some.